Hey, low rise. Oh, you didn't start it.
Oh.
No, I've started already. You can't see it, but I haven't already started, so probably she will hear it. Anyway, Louise, so if you're listening to this recording, this is actually the second half. The first half was spent just revising 8A. Okay, so the second half now is we're going to go through the new chapter, which is division of polynomials. Okay, so you guys should be okay with long division, right?
I suck.
Yeah.
Alright, guys, have a look. Let me show you an example of long division. 1234, well, 1, 2, 3, 4, 5, 6. Long division of this by, let's say, a number like 8, for example. Okay? So first, you need to take these two, divide by 8, which is 1. Right? Okay, like how many 8 goes into? Well, you actually take this one, you divide by this, you get 1.
You have like the 4.
Hmm?
You have like 4 at the end.
Yes, hang on. And then you need to continue by doing the reverse, which is 1 times by 8. And that will give you the number that you actually subtract by. Well, 8, sorry. Make sense? Yeah? So the idea is you find out, okay, what number here, when you multiply by this, would get you the number closest to 12. And the number closest to 12 from 8 is 8. And that's times by 1. Okay? And then you go 12 minus 8, which is 4. Then you start dropping all the other numbers down. 3, 4, 5, 6. And then next would be, we'll take the next, the first two numbers again, 43. So once again, it's the pathway of finding, okay, which number, right? Which number, when you times it by 8, will be a number closest to 43. 5, yes, because 5 times 8 is 40, correct? You see that process now?
Yep.
Yeah? Then you do the subtraction. Remainder 3. Drop the other numbers. 4, 5, and 6. And just keep repeating. So then what's the next digit, Amani?
34. Oh, wait, no. Sorry, I was reading off the bottom.
Okay, so what's the digit? Here.
Rocks, please.
3.
No, 3 times 8 is 24. It's not closest to 34.
4.
It's 4.
4.
Because 4
32.
is 32, yes. 4 times by 8 is 32. That's closer to 34. Right? That's the closest without exceeding
Did you do the
34.
smallest number though?
No, the largest number possible to be to make it closest to this one.
Oh, okay.
Okay? Yeah, the largest factor. Because otherwise, okay, what happens when you put 3 here? It will be 24, right? And when you subtract it, it's 10. This is bigger than 4. That's, the remainder can't be bigger than the divisor. Okay? So that's why this one has to be 4 and this would be 32. So then subtract that, now remainder is only 2. That's when you start dropping the other numbers. 256. So 25 divided by 8 is
3.
This time it is 3. 3 times 8 is 24. Subtract that, you get 1. Drop the 6. This one actually no. I'll change it onto a 9. I'll change it to a 9 and you have to see that why I want to do that in a second. So change that to a 9. So that would be 19 divided by 8 is Amani. Last chance for you to do this part here. What number goes in here? 2, correct. And that would be
16 remainder 3. No. Yeah, 3.
Yes, it is 16. Does it make sense, Amani?
Yeah.
Yeah, you times it down and then the remainder is 3. So I can write this as 1, 2, 3, 4, 5, 9. If you divide that by 8, what is the answer?
1, 5, 4, 3, 2.3.
Remainder 3.
2 remainder 3.
Yeah.
Okay.
I
Okay.
still suck, but
Right? Wait. Or you can, so the remainder 3 part is what you say, but algebraically, the remainder is written as plus 3 over 8.
oh,
Why is that the case?
because it's like you split it. You can
No, it's not unprofessional. It technically is correct, but I'll show you. Okay, wait. Guys, pause. Wait, guys, if you were to combine this, what happens? First, you times the top number by 8, right? You times this one by 8 to make it over 8, right? Yeah? And then plus 3 over 8. You see? When you times the top number by 8, you should get what number? You should get this. right? So this part is the same as, is almost the same as this, but you need to add another 3 to it because the remainder is 3. Does that make sense? So putting it this way, okay, actually maybe I'll write it in a slightly different way. So let's just say 1, 2, 3, 4, 5, 9 is the same as that number there, and then you times by 8, right? And then you plus the remainder, which is 3, right? Make sense?
Yeah.
Yeah? Now, wait, look what happens here. I divide both sides by 8. Okay? If I divide both sides by 8, the left hand side is the same. We'll keep it. So just write it as this number when you divide by 8 is equal to. Now there are 2 terms here. That's 1 term, that's 2 terms. I'm splitting up the fraction. So I split up the fraction into 15432 times 8 over 8 and then plus 3 over 8. Does it make sense? Instead of adding fraction, I split that into 2 separate fractions. And look what happens. The 2 8s here will cancel out. So which means I've got 1, 2, 3, 4, 5, 9 over 8 is equals to this number and then plus 3 over 8. Do you see where the 3 over 8 comes from now?
Yeah.
Yeah? You have to divide both sides by 8, and then when you simplify part of the fractions on the right hand side, it will be the quotient. Okay?
Yeah.
Now I will show you guys an actual polynomial division.
Wait, so are we just going to be using that?
You're using long division in order to divide polynomials. This is somewhat of a strange operation, but hopefully it will make sense. We'll see. So 8b. Okay. Example 5. Divide this polynomial by x plus 2. So this chapter we'll do it bit by bit. I won't explain everything all at once, otherwise you guys will be very confused. Okay, so divide this by x plus 2. Same thing, you take that number there, right? Actually I'll write it in the middle. So x cubed plus x squared minus 14x minus 24. Divide that by x plus 2.
Is that where I like split the 2 numbers and then I have to divide each of them like a rainbow sort of thing?
No. Good guess, but not in this case.
Oh.
So this is when you actually look at just the leading term of each of the polynomials. Okay, Ashwin? No, you're struggling with this one? So see, it will make sense now. So look at the leading term. Now the idea is what term, right, in here, when you multiply to this, you would get the exact same thing as x cubed.
X squared.
Is x squared. Do you see that, Ashwin? Yeah, Daniel? Okay, it's the same step, right? So you find out what goes in here. So that's x squared. When you times x, you get x cubed. But there are 2 terms over here. So you also need to times this by the other term to get the next part, which is 2x squared. Well, plus 2x squared.
Ew.
Does it make sense?
Yeah.
Yeah? And then, does it make sense, Ashwin? Yeah? And then you do the subtraction. So when you do subtraction, notice that the first term will always cancel out, right? We always cancel out with this one because we want something that will cancel out the first term so we can continue. So when you cancel that one out, x squared minus 2x squared is negative x squared.
Wait, what?
Yeah, because we are subtracting, right? So it will be x squared, 1x squared, subtract 2x squared. Because we're doing subtraction. It's like how here, it's x cubed, subtract x cubed, which is 0.
Oh, I thought it was only the one question. I didn't know it was like the 2. Like, I didn't know it was x.
You had to subtract both of them.
X cubed and x squared.
Yes, both of them, right?
Like you only circled x cubed, and I was like, oh, was it only x?
No. We actually subtract both of this. I was doing it bit by bit.
So then
okay,
you can
but
do
yes.
the same thing for negative 14x minus 24.
Yes, but it will be subtracting 0.
Yeah, right.
Right, which means nothing changes. So you actually just drop them down here.
Yeah.
Okay, Ashwin, does it make sense? Yeah? Now, what is the next term then? What is the next term up here? Remember, we want, when it times into this, you get the same as this. So essentially, what times into this would get you negative x squared?
Wait, what times?
Yeah, the question mark. What is the question mark? So that when you multiply with x, you get negative x squared. Because we want it to be the same. Because remember,
Negative x?
Yes, it is negative x. Does everyone see it?
Yeah.
Yeah? So negative x, when you times into positive x, you get negative x squared. Because when you subtract that, negative minus negative will be, basically these two terms are the same thing. So when you subtract them, you get 0 again. Right? That's how you start cancelling out term by term. Okay? So, but remember, there are two terms here, so you need to times the negative x by 2 as well. Right? Yes, negative 2x, so that'll be negative 2x here. Now, this is the tricky part. Pay attention. This one would be 0. What is the number that goes here? Anyone? Any guesses?
12x.
12x? 12x is
Negative.
negative 12x is better. Okay? Okay. So why is it negative 12x here? Because you're doing negative 14x, subtract negative 2x. Right? Because subtract negative 2x means you plus 2x.
Oh no, not that. How did you get to 2x again?
You take this one, you times it by the other term, that will give you the second term in the expression here. Yeah? Looks a bit strange, right?
Yeah.
Yeah, but that's how it works. That's how long division of polynomials work.
Yeah.
You find out what is this next term by finding what terms times into the first one would get the same as this, right? But then you need to also multiply that to the other term. So remember, it's like the rainbow thing. Okay, so you multiply to both of them. You multiply to x, you get the x squared. So you align that with x squared. When you multiply that with 2, you get negative 2x. So you align that with the x term only. So that there will be like terms. So you can do the subtraction. So x squared minus x squared, negative x squared minus negative x squared would just be 0. And then this one is negative 12x. The negative 24 drops down again. Okay. Ashpreet, what's the next number here? Ashpreet, only. No one else says anything.
What's the next number where?
What is the next term here? What's all of the instructions? Do you know what it is?
I don't like this already.
I know.
I don't like it.
Oh, the skill will come.
This isn't a rainbow anymore. It's like an octopus.
It's sort of a rainbow because you're timesing it by each of these terms.
It's a stretch.
Yeah.
Literally, it's a stretch.
Okay, Amani, what do you think? Remember, we want something so that when you subtract, you get 0 here.
Negative 12.
Yes, it is negative 12. Very good, Amani. Very good. Negative 12. Do you see that, Ashpreet?
Yes.
Why? Because negative 12, when you times this, you would get negative 12x, which is the same. And when you subtract it, you get 0. Okay? So Daniel, what is this one here?
It's
Wait, what?
12. No, negative 12.
Remember, you gotta times the next term.
Oh, wait.
2.
Oh, wait, am I finding out what times 2 equals negative?
No. So once we've got this number, you times that with the 2 here
Negative
to get the next one. So yes, it is negative 24.
Sure.
Okay, so think of it this way. To get the line that you can subtract by, right? You need to find out what number this is, and then when you multiply that, so essentially you're finding out that okay, that's negative 12, and then you need to time it by the divisor, so times x plus 2 like that. Does it make sense? And when we expand that, we get something that when you subtract this, you get 0. So when you expand this expression, it will be negative 12x and then minus 24. Does it make sense? Because each of the term here needs to multiply by the entire x plus 2. Right? It's like how negative x times x plus 2, when you expand that, will be negative x squared minus 2x, which is what goes in here. Right?
It's become puzzling.
The big and puzzling? Okay, well, we'll try another one.
Yeah. Can we do like an easier one? Actually, never mind. Sorry.
I can show you an easier one.
Yeah.
Okay, let's start with something a little bit easier. I'll give you an example. So let's say x squared plus 3x plus 2. Okay, and then we divide this by x plus 1. Okay, divide this by x plus 1. Now again, the idea is that we want a number that when you times it by x plus 1, it will be something that you can subtract and cancel off the x squared. So what do you need here?
Could you repeat the question?
We want something that when you multiply with x plus 1, you would get x squared and then
You gotta
plus
do the little subtract sign.
something.
Oh, 1 square.
Yeah.
X.
Yes, it's just x, right? So essentially, the number that we just found is x. So you put that here, and you times this with that entire divisor, right? To get the next, to get the terms that we're reducing the division by. So then x times x plus 1 is x squared plus x.
Okay, never mind.
Does it make sense? Yeah? Because you're multiplying x by the entire x plus 1, and you have to do the rainbow method. So you times it by this and times it by that.
Yeah.
Yeah? Okay? So then you get your x squared plus x, then you do the subtraction, then the x squared will be gone. 3x minus x is 2x plus 2. So once again, you're finding something, right? Something times into x plus 1 that will get you 2x plus something else. Right? Because you want the 2x to get cancelled off. Okay? So you need to find a number here that when you times into x plus 1, it will become 2x. What would that be?
2.
2, yes. Or just plus 2. Does it make sense, Ashby? Yeah? So then the 2, when you times into x plus 1, would be 2x plus 2. Right? And then you subtract it, the remainder is 0. Which means that that expression there is essentially the same as x plus 1 times by x plus 2. Okay? So that's polynomial long division.
This is so tricky.
It is tricky, okay? It is tricky. Now the next question, I will. Right, let me see. Okay, I'll show you another example from the textbook. Okay, example 6. Oh, actually, no, not yet. Okay, guys, go to get your notebooks out, and then we'll start working through question 1. Okay, I will also slowly work through it, but you need to try it yourself first.
I literally do not want this. I don't know.
Okay, paper. Do the long division. Are you okay, Ashby?
I'm stuck.
Stuck at which one?
The first one.
The first one? Do you know how to get x squared? No? So you look at the first, the leading term of each polynomial, right? And you find the term that will make this leading term the same as that leading term.
Right, I get that. I just don't know what to do after.
After that, you gotta multiply the x squared down. You multiply this with each of this to get the expression here.
And then what?
And then you subtract them, like long division.
Ugh. What is that? I don't like this at all.
Okay, alright. Guys, have a look. I'll explain the answer here. So when you get up to this point, when you subtract it, this will be 0, that will be 0, and that will just be positive 3, right? So that means the remainder is 3. Remember how I showed you guys earlier where another way of writing the remainder is this thing there? So that's the remainder over the divisor, right? Remainder over divisor. Or I'll write this way, if you quotient. Okay, so all right, guys, have a look. If you have a number, right, a, and then this is equal to another number, let's say d times by q plus r as for remainder. Another way of writing that is when you divide this by the divisor, right? Divide each of them by the divisor, okay? Then that means that the result of the division is essentially the quotient, which is what we found, plus the remainder over the divisor. Okay, so the result they're writing is this thing in this form here. So when you write up to this point, what's the quotient? The quotient is the thing that we found. See, this is the quotient. And what's the remainder? The remainder is 3. This is the remainder. Okay, the divisor is what we're dividing by, which is that one there. Okay, so that's why the result of the division of our question A would be, therefore it would be the quotient, which is what we found. So x squared plus 2x, right? And then plus the remainder, which is 3 over the divisor x minus 1. So that's how the textbook got the answer. Okay? For example, that's a simple one. 22 divided by 8 is what? It's 2. Remainder?
Oh wait.
Okay, 2 remainder 6.
Oh.
Okay? 2 times, because 22 is the same as 2 times 8 and then plus 6, right?
Yeah.
Okay? So this is your quotient times divisor plus remainder thing. Okay? So what I'm writing is this. 22 divided by 8 is the same as 2 and then plus 6 over 8. Okay? So this is in the form, the result is in the form quotient plus remainder over divisor. Does that make sense? So this is the result of the division, you know, the result of the division, and then this is just the remainder. Okay? And it will always be over the divisor. Does that make sense? Okay,
Yeah.
alright.
Could I leave mine like that?
This is gonna be the death of me.
It was like
no,
something
it's
similar to what we did in school.
Daniel, did
I
It's
can't remember,
similar?
It was just
No.
it's not x minus 1 equals 2.
no, no, I did equals to that thing.
Yeah, so this is not x minus 1. This is so technically the left hand side of that is x cubed plus x squared minus 2x plus 3 divided by x minus 1, then equals to that.
Oh, okay.
Yeah, so when you divide the first polynomial by the other one, then the answer is that long thing there. Okay, so that should be the result. That's why if you want it to be correct, you have to rub out the x minus 1 equals. Rub out this part there. Alright, so that's the answer for question A. So please redo question A first and then see if you can get it right. I'll go around helping each of you out. Yep, that's it. Now I'll start working through question B.
I kind of get it now.
Alright, you just need more practice. It's not too bad. Once you get it, it's quite I guess fun maybe to do.
Fun.
One day you'll find it fun. One day.
It's like the kind of fun like throwing rocks at a window when you know someone's home, but you don't know anyone's home.
Not that bad. Not that bad, Daniel. Not that bad.
Like throwing rocks, like you're like in the dark and you can't sleep and you know something's in the room, so you start throwing things at whatever patch of darkness.
No, it's
it
not
might be
not
there
that bad. Not that
until-
bad. Anyway, question B.
Stop listening to Kanye West.
What do you mean?
It's getting into your mind.
No, Kanye has nothing to do with it. He makes gospel music now. What are you talking about?
Hey, they should really play that chapel.
Guys,
Praise God.
Ashpreet, what is the first name in question B? If you don't know, focus.
The first
Same with
one.
Daniel.
2x.
Wrong.
I better focus. Negative 2x.
No. You want to get 2x cubed.
Oh, this is cute.
Yep. So it is 2x. squared.
Yeah.
Yes.
Don't something wrong.
You sound like a room.
Okay, for question B, once you've done the first step, make sure you check with me to see
Wait,
if you get it right, yeah?
Oh, subtract.
Subtract, yeah. So subtract both of them.
Can you see what I've done wrong? I've done something. Don't.
That's wrong, because you're minusing 2,
Why?
right? It's x squared minus 2x squared. What's the answer?
Oh, this thing here.
No. So this is correct, but this is wrong.
Yeah.
What's x squared minus 2x squared? Right?
X.
Because it's x squared here and then minus of 2x squared. Right? So minus of a plus is just minus. So x squared minus 2x squared is?
1x.
No. And this is the can't practice again. That's why, that's what I mean. It's negative x squared. Because it's 1 minus 2. Right? So you small positive minus a bigger negative is negative 1. Right? The answer is a negative, and it will be the difference between the two.
Wait, how do I do B?
Okay.
B?
Oh.
Do the
But
division.
then there's something wrong with this part here.
Yeah. So because this is negative, yeah, so that's negative x, so that would be negative x squared, and times that would be negative x. Yeah, so once again, negative 4 minus 1 is a plus, right?
Okay.
Negative 4 plus 1 is?
5. Oh, 3.
3?
Negative 3.
Negative 3. Do you see why you have to do the can't practice? You have to get it right.
Someone con.
Okay? I'm saying it again and again is because you see, this is your weakest part. If you get this right, this will be easy for you.
Because
It's just that one
this
thing.
thing is I can do it. It's just the negative parts they confuse
Correct.
me.
And do you see why I assign you all of the negative stuff on can? Because you can do it. If it's wrong, redo it. Check it, can tricks for you. Bam, you can do 20 questions and get
Wait,
the
so
answer
that's
straight
a
away.
positive, and then this will be negative 3.
Yes.
And then this, then what do I do after?
So you drop down what's remaining, which is 3.
So it's positive 3, so.
Yep.
I have a question. Why'd you write negative x squared there?
Because if it's x squared,
Is it
subtract
x squared minus 4x plus 3?
2x squared is
I've gotten
negative
to
x.
that point, but
And then, oh no, I just keep going.
because I know where to go, I just don't know where to go.
Okay. Now you gotta find the next number that when you multiply, you get the same as this.
You go to chat GPT.
Negative x.
Yeah, negative x. Yes, negative x.
Think of some-
And when you times it down, Ashpreet,
I don't even like
Ashpreet, do you get up to this point yet? Have you got past this point yet?
Almost.
Almost. That
I
means a
just need to
no.
write the
Focus.
first 3. Whoops. Now
Keep
I'm
going.
To the point.
Yep.
And then-
Wait, don't I have to
And
do
then
that
what
times
else is?
one? Yeah, that.
And then you do the subtraction.
Fudge cakes.
Yeah, same steps, guys. So subtraction minus x, that will be 0, and then negative 4x. So at this point here, it will be negative 4x. Subtract negative x, which is the same as negative 4x plus x, which is negative 3x, right? So then this one would be negative 3x plus 3. And then you find a number that times into this would get you closest to negative 3x plus 3. And that is negative x. Oh, sorry, negative 3.
Oh.
Because when you times into x, you get negative 3x, and this one will be minus 3.
Already to the
So there's no remainder, is there?
There is a remainder.
Oh wait, hold on.
A remainder is 6.
Wait, what? Oh, because it's a negative.
Yep. So, no. Minus is a plus.
So therefore, it's 2x squared plus no, minus x minus 3 plus 6 over x plus 1.
Yeah, that is the correct answer for question B.
Nice.
Okay, if you guys are done with B, start on C.
I made one more. I have like one more thing to do, but I made a mistake on it.
Yeah, that's okay. It's
Really
a minor
one-
mistake. Yeah.
It's like one more thing. It's literally the only thing that's stopping me from getting the correct answer.
Yeah, that's fine. I'll get to you in a second. Guys, have a look. I'll show you guys one more example, and then you guys can actually do all the way to question 6. So this example is this one here. Okay. All right. So, okay, what do you notice about this polynomial? Okay, Ashrik, pens down. All right, Amani, pens down. Have a look. Okay, what do you guys notice about this dividend over here?
It's non-monic.
Good, very good. It is non-monic. Okay, and what else? That's a good observation, not the one I'm looking for. But it's a good observation. Okay, what else? What else do you notice about this dividend here?
Looks the same.
Is it a perfect square?
It's not a perfect square. Now I'll tell you something is missing. You can't actually... Amani, I think you might know what this is. What is missing here? What is the missing term? Because normally it's like x cubed plus x squared plus x plus whatever number constant, like plus 4 for example.
Oh, there's no square.
There's no square. If you see something without a square or with a missing term in the middle, you have to add that in. Okay? Plus 0 x squared. Why? Why is that the case? Because when you're dividing it like that, remember the first number would be, let's say, to get 3x cubed, you need 3x squared, right? So when you times it, then you get 3x cubed, and when you times it by -2, you see, negative 6x squared. Imagine if we didn't write this, you wouldn't be able to subtract these two, because they're not like terms, right? So that's why you have to write the missing term. In this case, is an x squared term, and then you can do the subtraction here, right? Subtract that. So Luis, if you're listening to this, I'm writing it in a slightly different form where I subtract both of this in the bracket, so it's a bit easier to see that is a subtraction. Okay, so subtract this one will be 0, just cancel out. 0 minus -6, so remember this one here is 0 minus -6, which is 0 plus 6. Okay, so that would be positive 6x squared. Alright, and then this one will drop down, so plus x minus 3. Now that means that the next one will be 6x squared and x, so we need to get that, so that will be plus 6x. Then you multiply this one down again to this entire expression, you would get 6x squared minus 12x. Okay, and then we subtract that one more time. The first is gone, cancelled out, and the next is 1x, okay, minus negative 12x is plus 12, so that will be 13x minus 3. Okay, then the last bit will be 13, so that will be just plus 13, and then once again you times that with this, you'd get 13x minus 26. Then you do the final subtraction. Again, minus 26 is plus 26, so that will be 23. So that's the remainder 23. So then you write the final answer. So the final answer is in the form quotient plus remainder over divisor. Right? So the quotient is the result that we found. So 3x squared plus 6x plus 13. And then plus, what's the remainder? 23 over divisor x minus 2. So that's it. The only thing that's different in this question is you have to add the missing term, which is the x squared term. Okay, and the rest is the same.
Does it always have to be 0?
Always 0, because there's nothing there, right? There's nothing that means the coefficient is 0. Okay?
Yeah.
Yeah, so if it's missing the x squared term, you put plus 0x squared. If it's missing the x term, you put plus 0x. So the coefficient is 0, right? So you're going to do 0 minus something later. Okay, that is it. You guys should be able to do up to question 6. Now, I will specify what question to do on Discord. Okay, but that will be it for this lesson.